science at the end. We're taking a look at lenses. And we've just done some demonstrations, played around with some lenses. And I'm going to do my best to try to get this back on the screen. Here we go. Okay. As you guys put those in, we're going to finish these diagrams. So the first thing we're going to do is label which lens is converging and which is diverging. This lens, the first one we looked at on the board and stuff, spreads out. This is also known as a diverging lens. I told you to write it here. Now, it's a diverging lens. The shape is called concave. And if you think of the inside of a cave, you know what I mean? It's like that. Here's the thing. Concave describes the geometry or the shape of it. Diverging describes what the lens does to the light rays. And it is actually the exact opposite name combination as a mirror. Remember, converging mirrors were concave mirrors. Okay? So keep that in mind as we do this. Now, the diagram itself, parallel rays spread out. They spread out so that they spread out, and just like with the mirrors, we're going to have a virtual focal point. So I'm going to grab lines here. Try my best. There we go. I'm going to just make a focal point with dotted lines first. I actually don't need arrows. And I'm going to actually extend these a little bit. Then I'm going to make those solid after. So, then I'm doing this part to do the you guys are doing this too. Dotted lines, because this is, you couldn't actually see. And we're going to make the solid lines on the other side. So you're doing this right now as we speak, right? And I don't know if you noticed this during the demonstration, but something that goes right dead center through the lens just goes straight through. So, solid on the right-hand side of this. I'm going to just circle this middle. What would we call this point in the middle? Same word, same vocabulary as mirrors. What do we call the point where the light rays, the diverging rays, if you trace them backwards, seem to come to a point? The focal point. This is a virtual focal point. Okay. It's actually a point, though. I put a big circle around it just to show you, bring the height. Now there's that knife. We also saw the convex lens. Convex lens came to a real focal point. So it's a little shorter. I'm going to just put all these rays here first. And And we're going to label this one a real focal. 1 second. Okay. Convex lens is also known as a, well, it's not diverging. The rays truly do converge. Real focal point, so it's a convergent lens. Once again, to repeat, the name combinations are the opposite of the curved mirrors, right? Convex matches with converging for the lens. Now, why do they do this? We've already looked at refraction with glass. When lenses are used, light refracts twice. Reflects to the normal when it goes from air to glass. And how do you draw that on that sign? Just with a rectangle. Then it refracts away from the normal when it goes from glass to air. We don't show this in our diagrams because it's too complicated. But the approximation when we just use the center of the lens, it's a good approximation. So what we're really saying is that this ray, actually right here, will go like, okay, it wouldn't quite work. But anyways, I'll show you the diagram right there. Thank you. So what we're saying is that really, hits, goes, and then refracts again. You notice that the normals, though, because it's a curved surface, are 90 degrees just to this point. Anyways, but it would be way too complicated if we did our diagrams like that. But they work because of refraction twice. Now, I wear glasses, other people wear glasses. Those lenses, you ever notice some people, it depends what kind of lens they have. Some people have glasses that make their eyes look bigger when you look at them and they take off their, and you can tell the difference when they take off their glasses, right? What kind of lens system must that be? If their eyes look bigger, right? Well, we were just handling them. They're converging. Now, the glasses you wear aren't these symmetrical football shape or hourglass shapes because they're very precise and stuff like this. I've got just a small diagram here. Just you've got all kinds of combinations, right? These two on the end are the ones we're looking at. They're the extremes, right? So your doctor or optometrist will give you a prescription. They don't ground the glasses. They send it away. You know, but the prescription tells whoever's going to make the lens how much curve and on which side and so on, right? Correct. Any questions right now? One last thing to go on here. That the diverging lens always makes smaller virtual. If it's virtual, it always matches with your image. All. Just like the diverging mirror, always smaller to the right. Whereas I won't list convex lens or the converging lens because you have a lot of possibilities. You have larger virtual, you have real images too. And real images, different types, just like the mirrors. Okay. Let's talk about down there. We'll take a look. Drawing ray diagrams. Now, I can go a little quicker because a lot of the rules are very similar to mirrors, except the light actually doesn't bounce off. It goes through the lenses. So they're similar. We only need to use 2 of 3 rules. I tend to use rules 1 and 3, but whatever you like. Rules 1 and 3. Well, I've got the diagram matched here. Rule 1. I'm going to use this. Ray travels principal parallel to the principal axis, refracted so that it merges and goes to the focal point, the principal focal. So it hits here. This is rule 1. Goes through the focal point. That's very similar to the mirrors, right? Now, I don't use rule 2 as much, but if it goes through the, now, because it's glass, that is the same side. You see how I had an F prime there on the left? It's the same distance away as the true focal point, but we just use it for geometry reasons. If it goes through this, secondary focus, it'll hit the lens and then go parallel out. I tend to use, though, the center rule. The third rule is the rule I like because it's really easy. It goes through the optical center of the lens. It just keeps trucking. Wherever two things crisscross, and now you guys know, you have an object, and we tend to use an arrow because it has a definite top. The image drawn to the principal axis will be inverted. Always draw your images. Here's an eyeball looking at it. Now, the same rules apply to a diverging lens. Because on a diverging lens, or a virtual focal point, it's on the same side as the object. So, the first rule is parallel to the axis, line it up with the focal point, and then make the solid line divergent going out. I'm going to skip the second rule. I just don't recommend it. Go through the third rule. You can see the second rule. Third rule is always easiest. Just go straight through. Everybody cool with that? So in this case, unlike the center of the mirror, the center of the lens is on the lens. Okay? So, surprise, surprise, we're going to try these. And just like the mirrors, we've got the same kind of scenarios. I'm going to label some things. The same side of the object on a converging lens. Converging convex. F prime to F prime. Twice that distance. Oh, square there. Okay. This is the true focal point, and this is 2 times that focal length. That kind of works for object placement. Kind of works like the center of a mirror. We'll see. We're going to try some things out, and then we're going to fill in the characteristics, the same types of characteristics as a mirror. Okay. So, I told you I prefer just using 2 of the rules. We'll do that. Here we go. If it's parallel, go to the dead center. Right? If it's parallel, it runs through the focus. Now, do you guys remember when the real image, or when the object was further away from the center, we got a real image. Now this, we get a real image, but it's going to be notice. If I wanted to, I could do the other one if it passes through this. Then goes parallel outward. Also crisscrosses there. But I'm not suggesting use the center rule always. It's so easy. Okay. Now, since we had the object erect or upright on the left side. Draw the arrow tip back to okay, so to list the characteristics. The type of image, what would we say? Is this real or virtual? The orientation and type go hand in hand, right? Same as mirrors. As I talked too much. Is it direct or is it erect or is it inverted? Inverted. So that tells you it's real. This is like when you were standing, you had the lens and asked you to produce the image on your stomach. Sure. The screen was quite far away. You had a small image of the screen. So the size is smaller than the object. It's always size is relative to the object. And the location between W. Everybody's good with that? We'll do the object at 2F. Now on a converging mirror, when you had the object, this is analogous to the center. When you had an object on the center, what happened? You guys remember? You got a real image. How was the size, do you remember? Same size. We should geometrically get the same kind of results, but it'll be at the F. Object at 2F. I put 2F on there, but I'll label the other things. I know where my image is going to go, so I'm going to put my label above. Okay. So this one's fairly easy to count. Just because I like the third rule, I'm going to use it. And then I'll do the first one. There. Oh. Did I say wrong earlier? If it's at the center, it forms an image at the center on a mirror system. Well, this 2F, I think I might have said L earlier. Anyways, same size. So we're going to draw that in. Hello. We're going to need the same size, type, real. Inverted. Well, you're going to need the sheet. Same size. Location at 2F. Pause here. Actually, I wasn't using the video. Same rules. I'll just mention the object between prime and 2F. You're going to get a real, inverted, large image that's beyond 2F. Pause the video if you need to catch up with the drawings. We're going to actually demonstrate this now with a candle. You guys have already demonstrated this a little bit earlier. Now we're going to do virtual images with no image. Let's just take a look at this one here. If the object is at the focal point on the mirror, what happens? That's the flipping point. It flips from virtual to real, from converted to erect, and that's at the flipping point. You get nothing. But let's just see geometrically why it happens. Wow. I'll use the easy rule first, the center. Why is because the rays are parallel to each other when they come through the lens. So the rays are parallel when they come out, no image. Parallel lines will never meet. Maybe in geometry. Okay, so that's a fairly easy diagram. It's easy to understand. That's the blurry point. Now, when you're up close, this is when you use that lens as a reading lens, right? Or magnifying glass. Yes. Nope. No image yet. Yep. I'll wait for a second. So then, this we should be getting virtual and larger. We'll play around with this and see. You see something that's like, what? Okay, so the parallel. I guess they didn't label these, but this is too loud. Secondary. Prime. This. Now, because I know where the image is going to end up, I left a lot of space on the lens. So, we line up our array, focus, and then we line up with the center. See something happen. They're definitely not going to crisscross all the rays. They're spreading them. So we trace them backwards. We're virtual. Is that straight through? I'll see. Actually, here's what I'll see. I might have to fudge it a little bit just to make it. There you go. It might go slightly off the page depending on the angles. But the arrowhead would be there. This is your image, obviously. And it is virtual, direct, large, on, okay. Lastly, a diverging lens. Oh, wait for a second. For a diverging lens, same rules. You recall, and I'll show you what I'm talking about. I guess that's what I'll show you on. Our actual focal point is behind or on the same side as the object. So we're going to label these on a virtual or on a divergent. all I need. But anyways. Use this rule and we should be done. Diverging lens. I'm going to use the rule I like best, going through the center. Now. Okay. Then the parallel rule. Line it up with the center of the lens itself. It goes parallel. It lines up with the actual focus. I'm going to do this with a dotted line and then make it solid on the right hand side. And to toss in the last bit here, tight is virtual, real tiny, smaller. There you go, just direct, smaller.